Hi everyone. I've had a couple of emails this afternoon about some work you're working on here in section 4.1 and 4.2 for pre-calc. So I just picked out some questions from your assignment, and I'm just going to call this assignment hints. So maybe if you see a couple examples, it'll help you complete your assignment for these two sections. Okay, so in section 4.1, the only thing I wanted you to try was to be able to convert from degrees to radians and radians to degrees. I'm not going to go into a lot of detail right now about what is a radian. There's a secondary video posted on Schoology. You can take a look there if you want to see what that has to do. Okay, so essentially here's what we're going to do. If I'm in degrees and I want to convert to a radian, radians are going to be in terms of pi for the most part right now. So I'm going to have you multiply by pi over 180. Okay, because on a unit circle, which we'll talk about in the future, pi radians is the same as 180 degrees. So it's really, we're multiplying this by 1. We're changing what it looks like, not its value. Okay, so you're thinking 60 pi over 180 degrees, and that will reduce to pi over 3. So 60 degrees is the same as pi over 3 radians. Okay, and going the other direction, if we start in radians, pi over 6, multiply by 180 over pi to do the conversion. Okay, in this case, the pi's cancel, and you're left with 180 over 6. So 180 divided by 6 is 30 degrees. Okay, and that takes care of your conversions. So basically, if you want a little rule of thumb, if you want to go from degrees to radians, you're going to multiply by pi over 180. Okay, and if you want to go from radians to degrees, you're going to multiply by 180 over pi. Okay, so there's a couple hints on those two items. Okay, next up, in section 4.2, you start talking about some of your basic trig functions. Maybe you remember from previous math class when we talk about trig functions, we're looking at SOHCAHTOA as a way to remember the ratios for the functions. Okay, for example, if I have a right triangle, which is down here, and I have a theta angle in the corner, maybe this is A, B, C, so you have right triangle A, B, C. When you're at A, okay, or here at theta, across the triangle, we have the leg opposite. The leg next door, this one is called the leg adjacent. And always and forever across from the right angle is the longest side of your triangle, or the hypotenuse. Okay, so when you do your ratios for sine of theta, okay, so I'm over here for sine of theta, I'm down in this corner. Sine is going to be defined to be opposite over hypotenuse. Cosine is defined to be adjacent over hypotenuse. Okay, so here's OH, AH. And I heard what you said when I said OH. Okay, joke. All right, keep going. Tangent is going to be the leg opposite over the leg adjacent, or O over A. Okay, now the cosecant, secant, and tangent you haven't done a lot with, but you're just going to be doing like reciprocals. Okay, so like cosecant is 1 over the sine. Okay, so you're flipping. So that means if sine is O over H, opposite over hypotenuse, then the cosecant is the reciprocal, hypotenuse over opposite. Okay, secant, 1 over cosine, which is going to be hypotenuse over adjacent, and then tangent, ooh, whoops there, my bad, I have a little typo here, hang on, let's get rid of this guy. Yep, I meant to write cotan. Okay, and that's going to be 1 over the tangent, or adjacent over opposite. Okay, so one of your questions on, let's see, the second page here, 328, says write 6 trig functions. Here's a right triangle, go for it. All right, so they have us looking at theta up here in the corner. So from theta, the 12 is on which side? If you said opposite, you are correct. The 5, adjacent, and 13 is the hypotenuse. Okay, so for sine of theta, opposite over hypotenuse is 12/13. Cosine, adjacent hypotenuse, 5/13. And tangent, opposite over adjacent, 12/5. Then to do the cofunctions, you're just doing reciprocals. So cosecant, 13/12, secant, 13/5, cotan, 5/12, and you're done. You've written the 6 trig functions. Okay, question number 9. They start you with sine theta equals 3/7. Okay, so let's start by sketching a picture. So I have a right triangle and I have an angle theta. I know sine is supposed to be opposite over hypotenuse. So from theta is opposite, so I'm going to put a 3 there. Hypotenuse, okay, 7. I don't know this leg adjacent here. Okay, so I'm missing this piece. I'll just call it x to call it something. So if I use Pythagorean theorem, okay, maybe you remember c squared equals a squared plus b squared. Okay, so hypotenuse squared equals the sum of the squares of the legs. We can figure out what this adjacent piece would be. So 49 equals x squared plus 9. So x squared equals 40. So x is going to be the square root of 40. I would say plus or minus, but since I'm doing the side of a triangle, I'm just going to use the positive root, and we could simplify that to 2 square root of 10. Okay, since we're just doing a quick exercise here with trig functions, I'm just going to leave it as square root of 40 to write the ratios. Okay, so we have to write all 6. So we need sine theta, cosine theta, tan theta. Okay, so if we do the sine, they already gave us that, 3/7. Cosine is going to be square root of 40/7. And then tangent is going to be 3 over the square root of 40. And again, we could simplify this and rationalize to get that radical out of the denominator, but for right now, all we're doing is writing the ratios. I'm going to just leave it there. Okay, so next up we need the 3 cofunctions. So cosecant, secant, cotan. And again, they are just the reciprocals of the sine, cosine, and tangent. So we're going to have 7/3. We're going to have 7 over the square root of 40. And we're going to have the square root of 40/3. Okay? So there's all your 6 trig functions, and we've answered the question. All right, note to you, in 33 to 39, okay, be sure your calculator is in the correct mode. Pay attention if they're asking you for a degree or a radian so that you get the proper answer. Okay, next was find theta in degrees and in radians. Okay, so in the next set, 41 to 47, you're solving for theta. So you're trying to find a missing angle. So whenever that angle is missing, you have to use the second sine or whatever your function is. So it looks like that on your calculator screen. Then you put the ratio in. So I'm going to just do 0.5 for 1/2. So second sine, it comes up with a little inverse thing, 0.5. And if you do that on your calculator, it should come out to be 30 degrees. Okay? Now, cotan. This one makes you nervous because, oh, I got to find the angle. There's no cotan button on my calculator. But from previously, up here at the top, we know cotan is just the reciprocal of the tangent. So if we rewrite this problem as the tan of theta and then do the reciprocal, so square root of 3/1, or just square root of 3, then we can find theta by doing second tan square root of 3. Okay, and if you do that, you should get a 60° on your calculator. It did also say for radians, so if you convert this like we did at the beginning, so like 30 times pi over 180, you'll find that to be pi over 6 radians. And 60 times pi over 180, you'll find to be pi over 3 radians. Okay, all right, lastly, solve for the variable. All right, so you always identify where the angle is they're giving you. Okay, and then what are the parts? Okay, so in respect to the 34, we have an opposite, and x is sitting on the hypotenuse. So again, OH, we have sine. So we'll say sine of 34 degrees equals 15 over x. Okay, then you got to go through here and do a little solve, multiply both sides by x. So x times the sine of 34 degrees equals 15. Divide both sides by the sine of 34. Okay, so then this becomes a calculator problem. 15 divided by sine 34 should be around 26.82, and you're done. Okay, so hopefully if you took time to look through this, it gave you a little help with your assignment and kind of filled in some gaps in what you might remember from Algebra 2. Have a super great day, everybody. Thanks for watching. Bye-bye.